Next, this is our present topic for the session 2. It's nothing but states of matter. What do you mean by states of matter? How many states of matter are there, children? How many states of matter? In general, it's a solid, liquid, and gases. One more state is the plasma. Yes, there are 4 states. Actually, according to your standard, we'll go a little bit depth with the 3 states, and one more state is also there. That also we'll discuss. Okay, what are the 3 states of matter? Solids. 5. Arnav, what are the one more states of matter? Arnav?
Ma'am, Einstein-Bose condensate.
Yes, Einstein-Bose condensate. Why I didn't say that, I'll say at the end. Okay. So, solid, liquids, and gases. Einstein-Bose condensate is nothing but, we'll read about plasma over there. Arnav. Yes? Solids, liquids, and gases. So these are the 3 states of matter. What are the main definition? Why we call it as a solid? A solid is a state of matter which have definite shape, mass, and volume. This is a solid. It is having definite shape. When we place the solid on a paper and we draw the outline of the sample. Okay, the solid. We just draw the outline of the sample. When we place down the sample or the matter, we can see a definite shape, and we can feel the mass, and it occupies the space. Yes? Then we consider it as a solid. Examples: ice, wood, and many more, etc. Okay, we know about the solids. Yes or no? So in this solids, we are going to discuss about the properties of solids. What are the activities considered in this solids? What is the first property of solids? It is having definite shape, size, and volume. How these solids get the definite shape, size, and volume? If we consider solid, this is a particular solid substance. So we feel that these are the particles present inside the solid. These are the particles. Is there any gap between the particles, children? Is there any gap? No, there is no gap because it's all the particles are very close to each other without any gap. Without any gap. Without any gap. That means when we compress the solid, when I want to compress this, is it compressing? Is that the shape changing? I want to compress this. Is that the shape changing?
No, ma'am.
No.
No, ma'am.
That means the compressibility is negligible. The compressibility is negligible. Again, you'll be having a doubt. Ma'am, in case of sponge is also considered as solid, but it is highly compressible when compared to this duster. Both are solids. How can the sponge compressible? Because here the particles of sponge, there is no gap between the particles of the sponge. But here
And they have tiny air pores.
Yes, there are tiny air pores within the particles. So these tiny air pores are filled with gas, air. So when we compress, what happens? The air expels from the solid, from the sponge. The air expels from the sponge so that they compress. And again, when we remove our hand and we remove the pressure, what happens? And again, the air occupies the spaces. But we can see the definite shape of the sponge. Am I right? We can see the definite shape of the sponge. And the density is less when compared because it is filled with air. It is filled with air. Understood? Okay. Next one, high density. Density is high. High density. Why it is high density? Because the particles are very close. The particles are very close. So what happened? Automatically, the mass of each particle will be considered. So the mass also the density also increases. Yes or no? Yes, children?
Yes, ma'am.
Yes. So here, here, right, first one is what? It is having definite shape, size, volume. And the second point is compressibility is negligible. And the third one, it is having high, it is high density. Solids have high densities. Solids have high densities. Next one, intermolecular forces of the solids are more. Intermolecular force. How they are binding, children? If the molecules are present, is there any external force to keep the solids particles to come closer? I'm applying any force to keep the particles in the duster to come closer? No, I'm not applying any force. External force is not applied to keep the particles to come closer. The particles itself is having some force. Is nothing but intermolecular force. What is it, children? Intermolecular force. With this intermolecular force, each particle is attracted to other particle and they are very close to each other. So that when we compare to other states, solids are having intermolecular forces are very strong. Understood? So at this pandemic situation, we need to be very strong like solids. Yes or no? We can compare? Next, dimensions of solids do not increase in large or heating. Dimensions of solids do not increase in large or heating. What do you mean? What do you mean by dimension? Expanding. When you keep on heating the solid, so the dimensions doesn't increase. When you give more external force, then only we can convert it into sheets, like malleability. Understood? So the dimensions doesn't increase much more difference when you heat it. Okay, for example, if you heat the liquid, what happens? The particles will move a bit far. Why? Because the force of attractions are weak. Next one, diffusion is very slow or very low. Diffusion is very low. They won't intermix by their own. Solids, they won't intermix by their own. That's why the rate of diffusion is very low or very slow in case of solid. Until an external force applied, they can't intermix with each other. The best example, when we go with the chemical reactions, if we add the reactants, what happens? Some compounds, based on the reactivity, they react by their own. But some chemical reactants, solid chemical reactants, they require some external force or they require some external energy. Then only they can intermix or diffuse with each other. Understood? What are the points we considered for solids? Have you seen? These are the arrangement of the solid molecules. Or the particles present inside the solid. First one, definite shape, size, volume. Next one, negligibility, incompressibility. They are high tensor. Intermolecular forces in solids are very strong. Dimensions of solid do not increase in large on heating. Diffusion is very slow. Understood, children? These are the simple physical properties of solids. If you imagine the solid, if you know the arrangement of the solid, easily you can read. If you want, you can note down the points. Next one, liquids. What is the next one? Liquids. So here, yes. So a liquid is a state of matter which has definite mass and volume but no definite shape. Example, water, alcohol, etc. That means what? A liquid is a state of matter which has definite mass. It is having definite mass and volume but no definite shape. Why? It acquires the shape of the
Container which is kept in it.
Container which we carry it or which we hold it. So it takes the shape of the container. Yes. So in our situations in our life, we need to move like water. We need to move like water. We need to be strong like solids, and we need to go according to the situations. We need to set our mind. Yes. So a liquid is a state of matter which has a definite mass and volume, but no definite shape. Example: water, alcohol, any liquids you can take. Any liquids. What are the main properties of liquids? Definite mass, volume, and no shape, because it attains its shape by the container. Next, slightly more compressible than solids. Why compressible than solids?
The arrangement of liquid particles is, the particles of liquid can slide over each other, so therefore they are
That is
more.
that simply. Before going to the states of matter, I want to discuss two terms, children. Rigidity and another one, fluidity. Rigidity comes under solids. Fluidity comes under both liquids and gases. Okay. So before going to the states, so rigidity comes under solids, fluidity comes under liquids and gases. Bhumika, you have asked me about the Brownian motion is only restricted to solids. Is only restricted to liquids and gases. Why? Because solids are rigidity in nature. Understood? This also can give the best answer for the question what you have asked me. So rigidity is nothing but rigidity is solids are very rigid. They can't move by their own. Okay. Whereas because the particles are the force of attraction is very high, or they are least compressible. So that's why we consider solids under rigidity, whereas fluidity means liquids and gases. Why we consider the fluidity in case of liquids and gases are, here liquids and gases, the particles of liquids and gases, the force of attraction is less when compared to solids. So that's why they comes under fluidity. Understood? Yes? So, yes, ma'am. Very good. Very good. So when we see the molecular arrangement of the liquids, so consider this as a container consists of water molecules. When we see the liquid molecules, solid molecules, they are in a compactly arranged manner, in an order. They are compactly arranged in a particular order. When we consider liquids, the force of attraction is low when compared to solids. We can see the gaps between. That's why only liquids are used as a solvents which dissolve the solute, because to fill these gaps, the solute particles will occupy the gaps. And then in case of solids, is there any gap to occupy? Is there any gap to occupy?
No, ma'am.
That's why the rate of diffusion is very low in case of solids. When we consider liquids, here these are the particles, there will be a gap, or the force of attraction between the gaseous particles is low when compared to solids. Okay, so what is the first one? It is having definite shape, no shape, but it is having definite volume and mass. Understood? Then the next one is slightly more compressible than solids. Why? Because there are gaps. When we give the pressure to the liquid, so it's quite compressible because these particles will come closer. The molecules will come closer when we give the pressure on it, when we apply the pressure on it, on the liquid matter, so that these particles will come closer, so that they are compressible when compared to solids. When we apply pressure on the solids, what happens? There is no gap between the particles. They are tightly packed. So there is no chance of compressibility because that's what it decided it's that about negligibility or compressibility. Negligible compressibility. Right? Here there will be a gaps between the force of attraction is low, the gaps are present, so when we apply the force or pressure on the liquids, what happens? The particles will come closer. Okay, density is lesser than solids. Density is lesser than solids, but there are some solids which floats on the surface of liquid. That is, those are nothing but exceptional. In general, solids are less denser than liquids. When we go store in the water, what happens? The stone will go deeper or go to the bottom of the container because solids are more denser than liquids. Because the more number of particles are present in the solid, so they are very denser when compared to liquids. Next, force of attraction is less than solids. Force of attraction is lesser than solids. Okay, so the best example we can see the arrangement of molecules, how they are arranged. Okay, here the force of attraction is less. That's why they are a bit far from one molecule to the other molecule. If the force of attraction is strong, what happens? So there is a difference between a best friend and a friend. Yes? Best friends are nothing but solids. Friends are nothing but liquids. Okay, everyone we can't call them as my best friend. Yes? Yes or no? Yes. Best friends are nothing but they are having more understanding. They can share their views and they can share their thoughts. Okay? And everything. Why? Because the force of attraction between them is they are very strong. Okay? When your friend do anything wrong, so that if he is a best friend, he will definitely correct you. Yes? Yes or no? I think you are missing your friends because of this pandemic situation. Okay, whatever. So these particles, the force of attraction between the liquid particles are less when compared to solids. Okay, liquids expands far than solids. That's what I said. Not when you heat the liquid particles, what happens? Their kinetic energy will be more. Then what they'll do? They'll strike the walls of the container and they'll move. So that they can easily expand. Expands are nothing but giving more space between the particles. Yes or no? So when we compare with solids, liquid expands far than solids. Yes? So next one, diffusion is on ease. It's nothing but diffusion is more in case of solids. Intermixing with each other. Intermixing with each other. The best example, what we have done? Lemonade. Lemonade?
Yes, ma'am.
Milk in water. When you have taken like full cream milk, it's very thick. So what your mother will do, she just dilute the milk with very few amount of water. If you want the pure milk, pure creamy milk, what your mother will do directly? She just boil the milk and she'll give you because it's good for health. Because it consists of all kinds of fats, vitamins and everything. Okay, protein food. Okay, then what immediately if it is very much concentration is very high with the quantity of cream, then immediately what your mother will do? Your mother will add few amount of water in it. So by after adding water in the milk, no need of stirring that, immediately she just allow it for boiling. Yes or no? This is because of diffusion. The rate of diffusion in case of liquids are high when compared to solids because of gaps present in it. And we can't separate them. We can separate them by simple physical methods. We need to go for selected methods. When we go for the separation techniques, we need to go for the selected physical methods to separate the components present in the particular sample. There is a chance of separating milk from cream, so definitely we go for the separating process. That separation techniques we will see in the coming topics. Okay? Understood? Lemonade, milk in water. So what are the properties? Define liquid. Liquids have definite mass, volume and no definite shape. The best examples are water, alcohol or anything else, whatever you want to give the examples you can give. Definite mass, volume and no shape. These are the properties. Slightly more compressible than solids. Density is lesser than solids. Force of attraction is less than solids. Liquid expands far than solids. Diffusion is on ease. Why we compare these children? We can read the properties of liquids, properties of solids, properties of gases separately. But why we are comparing? When there is a comparison only, we can say that we can know the level of it. Am I right? Yes? How can you compare in a classroom? We can compare in a classroom with the top mark chain. Yes? Then that is your target and the least one. Then only we can know the level of that particular classroom. Yes or no?
Yes, ma'am.
So that's why we are comparing with solids. Yes? Have you seen the arrangement of the molecules in case of liquids?
Yes, ma'am.